Hello everyone. Our topic is Smart Badminton Court System and we are Group 11. These are my group member Wong Wai Kiat, Kong Iman Yanzhen, and Tan Hong Liang. Now I will introduce the background of the badminton court system and to enhance playing experience, improve training methods, and streamline court management. And we have using the Internet of Things to integrate with the camera and light bulb to control easily, and artificial intelligence to help us to predict to the ball status by the image. And we have using a data analytic to analyze the gameplay and visualize the data to the graph. The first problem statement is a traditional booking process is labor intensive, causing congestion and error during peak hours. Customer booking history and personal information are extensive and disorganized, leading to inefficiency, storage, and resource wastage, which hampers tracing user spending habits. Timely and up-to-date reminders are not consistently sent, risking court wastage if customers forget to attend their booking. And our objective is simplify the process, increase the efficiency, and reduce human labor. And the second is automate the recognition of the ball status and light intensity control in the badminton court. The third is collect the information and data so that company can fully utilize the badminton court resource after analyzing the data. User able to know the status of the badminton court has been booked or not and able to complete the booking by themselves.
For comparison of platform, there are three main services that we provide for cloud service, which are the AWS, which we're using for this course, Microsoft Azure, and Google Cloud Platform. So for their service, the service for AWS are covering for computing, storage, database, machine learning, analytics, IoT, and security developers tools. While for Microsoft Azure, the service for covering are computing, storage, database, AI, IoT, analytics, securities, and developer tools. While for Google Cloud, it covering for computing, storage, database, data analytics, machine learning, AI, IoT, security developer tools. For the pricing, there are some differences between them. So for AWS, we can see it's the pricing model per hour basis, while for Microsoft, the platform pricings are per minute basis, and for Google Cloud is pricing model based on per second basis. For the protocol that been used for AWS is MQTT, HTTP WebSocket. Microsoft Azure are using MQTT, HTTP, and AMQP. And lastly, Google Cloud is using only two, which MQTT and HTTP. So this is a table with of the overview of symmetries in service provided by the three major cloud platforms. So they name their services as different names. So the first row is represent as a compute service. AWS is named it as Amplify. Microsoft Azure named it as Azure App Service, and Google Cloud Platform named it as Google Firebase. And the second row is represent for the identity, and the third row is for API management. So here are some common services that owned by them.
Good day everyone, my name is Wong Wai Kiat, student ID 210574, and now we're going to present the front-end part and also some of the back-end services of our system. So on the screen, we can see that we are using the Visual Studio Code, and there are three .html pages here, which are the login.html, index.html, and also the logout.html. So the index.html is our first page that user that visit. So all this code we actually commit and push to the GitHub, and then we use the services in the AWS Amplify to link to the GitHub, and then we deploy our website in the AWS Amplify. So after successfully deployed, we can click the link here to visit to the web page and the website. So it will show the welcome message, and then it will let the user to click the below link to register or log in. So after we click it, it will load and then redirect user to the AWS connector that let the user to authenticate themselves. So here we click the sign as a new user, and then we have to sign up for a new account right now. Here we have to enter our our email and also the password. So the password have to fulfill all these criteria, only that you can register for account. So we click the sign up. After we click the sign up, right, we can see that the AWS connector, it will have the new, it will appear here, the email address that we key in just now, but the status are unconfirmed and not verified, since we not yet verified our account. So we need to go back and then refresh to get the confirmation code, and then go back to here to our web page to confirm our account. After we confirm our account, it will redirect us and log in to the main page. And we can see that the user pool is actually verified and also the confirm. So in the home page, we can see the welcome message, the congratulations, and also show the code availability, which will show which code is available during what times. So all this code availability is actually retrieved from these Lambda services. And then this Lambda is actually trigger and will access to the DynamoDB and retrieve the code that available. So in the DynamoDB, we can see that there are 4 codes, and while the 234 is actually set to true and available, which is the available, but the code 1 is actually set to false, which is not available. So which means that it will only show the 234 code that available. So if the user want to book the code, let's say the code number 2, and then it will click the book, and then the system will do the booking for the user, and then it will show a prompt out message. We show the code availability updated successfully, and click the OK, and then the system here will automatically update the code availability, and then the code that we booked just now is actually trigger the Lambda function here, which is update the code availability, and then after trigger it, it update the DynamoDB, and then we refresh it. We can see that code 2 is actually set to false, which is not available anymore. And then we go back to our homepage. User can actually log out by clicking this link, and then it will redirect the user to the logout HTML. So this is the logout page, and then user can log in again, and it will redirect the user to the console again to sign in for the user authentication. So that's all from me. Thank you.
So now I will continue to explain about how our system could send a reminder email to the user and how the user could do the self check-in and check-out for the booking. So several things we need to check before we can do it. So the first thing is that we must ensure that the user email address has already subscribed to our topic so that we can send an email to the user. And the second thing is that for our IoT devices, which is the light bulb, we should subscribe to a topic so that when the status have changed, then it will write a message here. And for the DynamoDB, we will use 2 tables, which is the code status and also the user appointment. For us to send email, we will need this Lambda function. We will check for the schedule date and also the today's date. If both are the same, then it will send an email to the user. So this indicates that they will have 2 booking for today's. So in the user email address, it will include the appointment date and also the appointment time. And here is the link for check-in and link for check-out. Please take note that for the check-in link, the link will only work when you click 10 minutes before or after the booking time. Means that if the time for this booking is 4:45, the earliest time for user to check in is 4:35. Means that the user are able to check in now. When I click on this link, then it will say that for the code number 3, the light bulb status has switched to on. And in our DynamoDB code status, the code number 3 the status will change to true. And for the MQTT test here, it will have this message, the light bulb for code 3 has been switched on. And for user to check out, the link is activated until 10 minutes after the ending time. For example, if the duration for this booking is for 2 hours, means that the ending time is 6:45. And the latest time for user to check out is 6:55. So for testing purpose, so I will click it now. So for the code number 3, the light bulb has been switched off, and in our DynamoDB, the status will also change to false. And in the MQTT test, the devices will also send a message saying that the light bulb for code 3 has been switched off. And if another case is that if the booking time is not yet reached, but the user click on this link like this one, 8:30 p.m. and user click on this link, it will say that the link is deactivated and this link is only activated 10 minutes before the booking date and time. So how we could do this is using this check-in out Lambda. This Lambda will do 3 things, which is it will check if the link should activate or not. And if it is activated, and user want to check in, they need to update for the code status in the DynamoDB, and they need to trigger an IoT message. So this is the overall how we can send and reminder email to the user, and how the user could do the self check-in and check-out for their booking. So that's all for this part. Thank you.
This is our architecture diagram. So for this module, we will utilize with this CCTV. So the CCTV will capture all the image when our player is on the call, and then it will connect with our IoT call, and after that, it will upload all the image that capture with the timestamp to our S3 buckets. After that, our Lambda will processing to call for the recognition video to detect whether the shuttlecock is inside the core or outside the core. So after that, we also using with the Lambda to call the functions to store all of the result that after processing with our custom label with the predicted result to our DynamoDB. Utilize all of our capture data in our DynamoDB table into a quick site report.
We are using the IoT core to implement the CCTV function. Here they have 4 sections. When we click on one, we can turn on the CCTV, and he will show the CCTV already run. And we're trying to upload the image to the S3 bucket first. Then we just provide the path, and it will upload the image. Then after upload, we can check on the S3 bucket, the image are upload. And then we can see on the IoT core console. So it have show the information with the CCTV. And then after upload, we can turn off and exit.
So we have also using this Amazon recognition custom label to train these machine learning models to detect whether our shuttlecock is inside the core or outside the core. So to train this, we have upload our data set, our image, and then we label with manually like this ball in or whether this ball is ball out. So after train this label, we can see our machine learning model with their model performance of F1 score, which is 0.844. On Lambda, we have utilized with adding the triggers S3 to connect with our bucket upload shutter code. So when there is some multiple images upload this to this bucket, then it will automatically trigger with our function here. So let's have an overview with the code. So in this code, our first function is to detect the custom label using the recognition, and we declare everything. And in here we have main confidence. This mean for confidence is like the thresholds, both for the custom labels. When it's more than 0.5, then it will choose with the higher probabilities as the result of the predicted labels. As we will record all the detected label information. And our second function is to save the predicted detected label inside to our DynamoDB. So we have also declared our table name, which is badminton tables, and also we determine whether the ball status is in and out. And then if in, then we label as in. And after that, we store inside the DynamoDB with the result out at the column of ball status. And lastly, this is Lambda handler, which is we define all the common parameters here. The model is the custom label models, and the main confidence is just now I mentioned is 0.5. Here is our DynamoDB badminton tables. The result will print in these tables inside the frame, and the ball status in and out will print at here.
Now we start to the quick side. We can input the data from the CSV file and put in QuickSight, and then choose the view to show our data. Here we can select the attribute. So this is the count of a variable by code ID and type. And another graph is show the ball status, which is in or out. And the total ball is 4. And here we can see the total appointment met on the each date. And another graph is the top reserve code, you can see the top, code 4 is the top reserve.